In addition to setting standards for the assessment, maintenance, and rehabilitation of underground infrastructure, NASSCO's mission is to assure the continued acceptance and growth of all trenchless technologies. Thanks to the hard work of NASSCO's Infiltration Control Grouting Committee, we are pleased to present this brief video. We also want to thank our sponsors for funding the production of this video and for bringing awareness to the many important features and benefits of grouting as a proven trenchless technology. Inflow and infiltration, or I&I, represent significant operational costs to storm and wastewater system owners. When allowed to exist over time, the additional water added to the system not only increases treatment costs, but decreases the total system capacity, contributing to sanitary system overflows, basement backups, property damage, and public health issues. Infiltration is also the leading factor contributing to the breakdown and removal of the pipe bedding and backfill that provide pipe support, causing damage in the form of pipe movement and loss of structural integrity. The removal of I&I is a very important step in system rehabilitation and management. Nationwide, I&I is almost half of all flow at treatment plants. I&I is a huge problem, and significantly, it only worsens over time if it is not removed. Through proactive mitigation, owners can decrease their overall costs while increasing system capacity, re-establishing pipe stability, and maximizing the longevity of their collection systems. Sewer grouting was specifically engineered in the 1960s to eliminate infiltration at all points of entry: mainline joints, service laterals, service connections, and manholes. Recent studies have proven that the grout injected through joints and defects to the outside of these structures creates a positive seal and is the most cost-effective way to deliver pipe stabilization, while eliminating the very process that destroys pipe systems. Aided by closed-circuit television inspection, the process of mainline grouting begins when a packer is centered upon a joint. The end bladders are inflated, and then an air test is performed. If the air escapes, we know that the joint is open, or, in other words, it failed. Grout is then pumped through the open joint to the exterior of the pipe. As it exits the pipe, the material combines with the surrounding materials providing pipe support, fills voids, and creates a watertight seal. A final air test is performed to confirm that the joint is sealed. The packer is then moved to the next joint, and the process begins again until all joints within the section are tested and sealed. Service laterals and their mainline connections are tested and sealed using a similar process. Utilizing a specialized packer, a lateral bladder is aligned with a lateral connection. The end elements and bladder are inflated, and then an air test is performed. Upon failure, grout is injected through the open joints to the exterior of the pipe, creating the watertight seal around the main line and lateral intersection, as well as the joints within the length of the lateral bladder. To complete the holistic approach to I&I removal, manholes are addressed by creating a curtain of grout surrounding the exterior of these structures. The process begins by drilling a series of holes through the manhole walls. Grout is then injected through the walls to the exterior, encapsulating the structure and creating a waterproof barrier. The grouting process is also an excellent complement to other trenchless technologies. Prior to rehabilitation using cured-in-place pipe, for example, grouting the mainline eliminates possible resin washout from heavy infiltration. After lining, the annular space between the host pipe and the liner can be sealed by injecting grout into that space, filling the void and preventing water from entering the system at the lateral reinstatement. State-of-the-art innovations in equipment and truck designs have allowed for the advancement of grouting applications. Analog or digital panel options provide essential feedback to the technician, assuring a proper seal. The grouting deliverables provide engineers and system owners quality data on joint testing, pressure, and material volume. An additional benefit is video proof, providing historical documentation of the sealed areas for management of assets. New packer innovations, such as long-span flexible packers and others, enable virtually all pipe defects as groutable. And by grouting first to control heavy infiltration, CIPP and other rehabilitation methods are more effective for long-lasting results. An additional benefit of grouting first is the ability to stabilize the sewer trench to eliminate pipe movement. This deliverable is a major factor in extending the life of the collection system. While there have been many recent advancements in grouting, many consider grouting to be the first trenchless technology. Industry pioneers laid this foundation in the late 1950s and early 60s with the goal to eliminate infiltration. Through the continuous efforts of engineers and practitioners, grouting is pushing new boundaries of environmental protection as a cost-effective, measurable, and sustainable method to rehabilitate our underground assets. To learn more about grouting, to become part of NASSCO's Infiltration Control Grouting Committee, and to download specification guidelines, please visit nassco.org or sewergrouting.com. Thanks again to our sponsors for making this video possible.